Hey guys, in this video we're looking at interval notation and linear inequalities. I have a separate video up for interval notation, so you might want to check that one out along with this. So we're trying to solve the inequality and graph the solution set, write the answer in interval notation. So inequalities they solve almost exactly the same as linear equations. There's one exception. We'll see that in a problem here in a couple examples down the road. This first one, so if I was just trying to solve this for x, I would go and I would divide both sides, and I get x is less than or equal to 7/4. And so less than, right? So less than is going to go this way. Greater than is the other symbol. It goes that way. Kind of a little cheater way in terms of the remembering which one's which. So for this, if you think of this as the arrow on the graph, if I'm at 7/4, it's going to go this way for less than, same as the direction. For greater than, the graph's going to go that way, same as sort of the direction if you thought of that as the arrow. It's just a way to remember it. The 7/4, I wanted to take a second and show you how to graph that on the computer because it's a little confusing. So if we think about what this is as a mixed number, and this is one of those places where the mixed number is kind of nice, 4 goes into 7 once with 3 left over. And so what I'm doing there is 4 goes into 7 one time with 3 left over. That's my 3/4. So I'm going to go to 1 and then 1, 2, 3/4. And the computer will have this set up where it's already kind of the right size increments, fourths. So you're just going to the whole number and then counting up 3. Or if it was negative, you'd be counting backwards that same number. So this was an equals, and when we're graphing, when we have an equals, we want to use a solid dot for our endpoint. We're going to use an open dot when we don't have an equals to show the endpoint isn't included. This is a less than, so our graph is going this way. And when you do that on the computer, make sure you draw the graph all the way to the end, and then it'll show up, and that means it's registered. And then we have to do this interval notation thing. So interval notation, I'll just kind of give a brief example of these two, but again, check out the other video for a lot of examples on interval notation. So what we want to do is we want to use the endpoints to describe the interval. So out here, this thing's going to go forever to what's called negative infinity, and we show that this way. So that little symbol is negative infinity. We use a parenthesis on the endpoint because we don't want to include it. So we'll have parentheses when we don't want to include things. We'll have brackets when we do. This is going to go up to 7/4. And then we'll use a bracket to show that we want to include the endpoint. So kind of the little key to this is if I have an open endpoint, that's going to be parentheses. If I have a solid endpoint, that would be something with brackets on it. And so that's sort of the interval notation. So small to large always. So negative infinity up to 7/4. So we can't include infinity because we can't get there. 7/4 solid, so equals. This next one, I'll divide over this 4. And then I get -5 is greater than x. So I wanted to do this one because it's written kind of backwards. So if -5 is greater than x, then that means x is less than -5. And so for me, I don't know, this just feels really backwards, so I always kind of rewrite them in this direction. But realize if the 5 is bigger than the x, or the -5 is bigger than x, -5 is still going to be bigger than x when we write it this way. You might have had that teacher in school who's had the shark or the alligator wants to eat the big thing, so it still does. So we're not reversing the direction of the inequality, we're reversing the order that we're writing it is all. So this is going to be x is less than -5. So this one has no equals on it, so I want to use an open dot to show that I'm not including, oops, that was 6. Ignore that one. How about on 5? So I want to use an open dot to show that I'm not including -5. And that's less than, so again, that's going to go this way. And so that would be my graph. And then my interval notation, we're going from negative infinity, always a parenthesis on that one, up to -5. Open dot this time, so now I'm going to use a parenthesis that goes with that open dot. So that's my interval notation. Number 3, I'm going to clear this fraction. So I'm going to multiply both sides by -2. You don't also think -2/1 if that helps. This I'll just do -2. And then this is the spot where inequalities are different than equations. So I cancel, I get x. This, when I multiply or divide both sides by a negative, I'm going to have to flip the direction of the inequality, and I'll show you why in just a second. But so instead of greater than, now this is less than, and we got 6 right here. So the reason we have to flip the inequality is, think about if I have, x is, actually not x, let's say we have 2 is less than 3. So 2 is less than 3 on a number line, but if I multiply both sides by -1, then I get -2 is less than -3. And if you look, -2 is bigger than -3. That's no longer true. So I have to flip the inequality when I do this multiply by a negative. Because -2 is greater than 3. So anytime you multiply or divide, reverse the direction of the inequality. So now we got x is less than 6, so that would be an open dot, another less than, going to -infinity. So my interval notation is from -infinity up to, but not including, so parenthesis 6. We have to do a little bit more algebra, and it's all. So I'm going to distribute this 2 across. So 2 times 3 is 6, 2 times -5 is -10x, and that's going to be less than or equal to -14. And then this solves the same way that the linear equations did. So I'm going to subtract the 6 over. So that cancels, and I'm left with -10x is less than or equal to -20, and then I'll divide the -10. And so notice right here, I am dividing by a negative, and that's that thing that makes me have to reverse the direction of the inequality. And it's always going to show up on that last step, because that's where you do your divide or multiply to isolate x. So then those cancel, I got x, but now it's going to be greater than or equal to 2. So coming up here to the graph, this one has an equal, so I want to use a solid dot. Finally got a greater than, so greater thans are going to go that way. Think of the arrow again. And the interval notation will look like 2 with a bracket, because it's a solid one, up to positive infinity this time, and infinity, again, always a parenthesis. So if this was in a lecture section, these next 3 would be the ones I would have you try. Rewrite that to make it a little clearer. So we got a -4/3 here on our x, so this is one where I'd want to use the reciprocal. So this would go -3/4. So that would give me 12 over 12, so that makes this x just positive x. What I do to this side, I'll do to this side. And I'm being mindful that I am multiplying both sides by a negative, so I do have to reverse the inequality. So that's going to get me to x instead of greater than, now it's less than. We could go -24 over 4 and get to the -6 there. Or 4 goes into 8 twice, times 3, -6, whatever works for you. So x is less than -6, right here. Graph's going that way. And then interval notation would be -infinity to -6. And then on the homework, some of the questions ask for interval, some of them ask for inequality. So this is inequality back here, this was interval. So just be careful to check out and read the directions and make sure you're giving it the form of the answer it wants. Next one we got, it's just kind of a straightforward linear, so I'll just bring the 6 over. And that's going to be 7x is greater than 21. And then I can divide the 7. I'm dividing by a positive, so no reason to switch a sign. And x is greater than 3. So I come over here to 3. This will be an open dot because no equals. X greater than, going that way. So from small to large, so I want to go from 3 and then up to infinity. Okay, so here, again, a little more algebra, so I'll distribute. Careful not to go 8 minus 6, right, because we got to multiply first. So this will be a minus 6x. Minus minus will make a plus 18 there. We'll just bring this down. I'm going to collect my terms first before I start moving stuff. So 8 and 18 would give me 26. I'll go ahead and bring my x's to this side. I could go the other way also. And then I'll bring my numbers to that side. So now I have 2x is less than negative 14. And then here's that divide step, so that's where I got to be aware if I'm dividing by a negative again. I'm going to flip my inequality. So x is greater than 7. So come up here to our graph and open dot. Greater than is going that way, so off to infinity. And we'd have from 7 to infinity. So these next three examples are how to kind of deal with fractions and decimals in these problems. So for this one, I would, I'd bring the 2 over first before I clear the fraction, just because this is pretty easy to consolidate. So I'll make a negative 3/2 x, that's all gone, less than or equal to negative 3. And now I can do the bit with the reciprocal. So I'm going to go negative 2/3 and negative 2/3. And if it helps, you can kind of put the 1 under that 3 to see the canceling. So here, that all is just 6 over 6, that's just x. And I did just multiply by a negative, so I'm going to reverse this. 3's cancel, negative and negative would make positive 2. So this will be a solid dot right here on the 2, and then x is greater than that, so the arrow is going this way. So all of our values are greater than or equal to 2. And then for interval notation, solid bracket this time, because of the dot, solid dot equals, and to infinity. So number 9 here, this one I would probably clear the fractions first, just because this is kind of messy. So I'm going to rewrite this down here. You know, and I did just notice if I bring this 3 over, it comes up a 1. So really that's probably what I would do with that. But let me show it clearing the fractions because it won't always come out that nice. So here I'm going to do the LCD on both sides. So I got 3's and 5s, so that'd be a 15. And so 15 over 5, that would leave me negative 3x. And then 15 over 3, that would leave me minus 5, less than. 3 goes into 15 5 times. 5 times 2 is 10. Or you could think of it as 30 over 3, still 10, whichever one you prefer. And then I'll just finish solving this. And if you look, so again, I just did this little trick with the LCD. If you look at this question and you look at this question, this is a much easier question. So this is really a little chunk of math worth learning. So add our 5 over. And then we divide out that negative 3, so another sign flip. So x is going to be greater than negative 5. So open dot to infinity, and then we're going to go negative 5 to positive infinity. So this one we got some decimals. And a good thing to do with the decimals is to just multiply by whatever power of 10 you need to clear the decimal. So in this case, I need to move this 2 decimal places, everything. So I'm going to multiply both sides. I'm just going to turn that into 100. So, and by 100 over here. And what that's going to do, that doesn't look very good. We'll go like that. So what that's going to do is just move this decimal on all of those values. And then it looks much, much easier because this is just boom, boom, and 3x. That'll be a 4. Moves twice, so 2x, and then plus 1. So much, much easier without the decimals. I'll just bring my 2x over. That'll give me x minus 4 equals, that's gone, 1. And then add 4 to both sides. Oops. You know, I have an equals here. Let's make it a, do I have it in notes? Yep, sorry, in the notes I have that as a less than. Let me get that fixed up. And so then x is less than 5. So come up here to 5. There's x less than 5, so we're going to go from, oops, it's equal So from negative infinity and then up to 5 with a bracket, because solid dot bracket equals. Okay, and these last three are the ones that in a lecture class I would have you try. So with number 11 here, we're going to go -8 on both sides. So that cancels. I'm left with -3/4 x less than or equal to -3. And then we'll do the reciprocal, -4/3, -4/3. That all cancels. X is less than or equal to. We can cancel our 3's. Double negative. Oops, it's not less than or equal to. Sorry. Greater than or equal to. I multiplied by a negative. Almost forgot. And so this will be a +4. So that will be a solid dot on the 4 and going to infinity. So bracket for infinity. For number 12, I'm going to definitely clear the fractions. So this time the LCD is 6, so I'm just going to multiply both sides by 6/1. 6/1. So with the 2/3, we can just think 2/3 of 6 is 4, or 12/3 is 4, or 3 goes into 6 twice, times 2 is 4, however you want to do it. Here the 6's would just cancel, leaving me that 5. And there, 2 goes into 6 3 times, so less than 3. So this was a terrible problem, and now it's a really easy problem. Again, really good technique. So we'll add the 5 over, and 4x is less than 8 divided by 4. And x is less than 2. So go to 2, open dot, going to negative infinity, so negative infinity up to 2. Okay, last one with some decimals. So this time we only have to move one place, so I'm going to multiply both sides by 10. And what that does is just gets us whole numbers everywhere. So now this is 9x plus 1 greater than 7 plus 3x. And now I can just get x's on one side and numbers to the other. So I go -3x, -3x. I think I'll remind you that you can do this all in one step. So -1, -1. So bring x's one side, numbers to the other. So 9x minus 3x would be 6x. The 1's cancel, greater than 7 minus 1 would make 6. 3x cancels. And then just divide over the 6 is all. And x is greater than 1. So here we are at 1, open dot, greater than going this way. And then our interval notation is 1 to infinity. Okay, that was a long one. So that wraps up 1.4.